Hello students, in this video I am going to solve numericals of exercise 1A, that is from chapter number 1, force, and the book is ICSE Concise Physics for class 10. Before I start solving the numericals, let us see some of the formulas that are going to be used. Torque. Torque is force into perpendicular distance between point of axis of rotation and line of action. So torque becomes F into D. Some of the units of torque are Newton meter, Newton centimeter, kgf meter, kgf centimeter, dyne meter, dyne centimeter, gram force meter and gram force centimeter. As you can see here, in some of the units there is a combination of SI and CGS unit system, and that is perfectly fine and acceptable in the numericals of torque. Now torque is a vector quantity, so we also must mention the direction in the final answer. There are two directions of the torque, anti-clockwise and clockwise. Anti-clockwise torque is taken as positive and clockwise torque is taken as negative. The second formula is moment of couple. Moment of couple is equal to any one force into perpendicular distance between two forces. And the distance between two forces here is also known as arm of couple. And the formula number 3 is based on the principle of moment, that is sum of the anti-clockwise moments is equal to sum of clockwise moments. So let us start. Numerical number 1. The moment of a force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of force. So what is given to us here? The force value is given 10 Newton. And the torque value is given 5 Newton meter. To find out the distance, we can use a simple formula, torque is equal to F into D, that is 5 is equal to 10 into D. So distance becomes 5 by 10, 0.5 meter. Second numerical, a nut is opened by a wrench of length 10 centimeter. If the least force required is 5 Newton, find the moment of force. So D 10 centimeter, force 5 Newton, find the moment of the force, that is torque. So once again, tau is equal to Fd, force is 5 Newton and distance is 10 centimeter. So the torque becomes 50 Newton centimeter. No need to convert centimeter into meter, as we know that in the numericals of torque, the combination of SI and CGS unit is permitted in the units. One more thing here, torque is a vector quantity, but here it is not specified that in which direction the wrench is rotated. So we will not be able to identify the direction of the torque in this particular numerical. Okay, so the final answer will have only the magnitude and the unit. Third numerical, a wheel of diameter 2 meter is shown in the figure with axle at O. A force of 2 Newton is applied at point B in the direction shown in the figure. Calculate the moment of the force about the center O and the point A. Now let us first understand what is the meaning of this statement, that moment of the force about point O. Now about point O means the axis of rotation is passing through that particular point. So here in the first case, we want to find out the moment of force about center O, meaning the axis of rotation is passing through the center point. And that is why the distance between the force and the axis of rotation will now be only equal to the radius of the wheel, that is 1 meter. So torque becomes Fd, force is 2 Newton, distance of force from the axis of rotation is 1 meter. So torque is 2 Newton meter. And it is very clear from the diagram that because of the force 2 Newton acting at point B, this wheel will rotate in clockwise direction. So we must mention that in the final answer, 2 Newton meter clockwise. Instead of writing this in clockwise, we can also use the sign clockwise torque is negative. So we can say torque is equal to minus 2 Newton meter. In the second case, we want to find out the moment of force about point A, meaning now the axis of rotation is shifted to the point A. Okay, it is passing through the point A. So here to calculate the torque, the distance between force and the axis of rotation will be nothing but diameter of the wheel, which is already given 2 meter. So torque is equal to Fd, force 2 Newton, distance 2 meter. So the torque becomes 4 Newton meter. Once again, from the diagram it is very clear that the wheel will rotate in clockwise direction. So 4 Newton meter clockwise is our final answer. Of course, we can also write minus 4 Newton meter as a torque. Fourth numerical. The diagram in figure shows two forces, F1 5 Newton and F2 3 Newton acting at points A and B of the rod. Distance OA is given to us 2 meter and OB is also given 4 meter. Calculate the moment of the force F1 about point O. About point O means the axis of rotation is passing through the point O. So torque is force into distance. Force is 5 Newton and distance of the force from the point O is 2 meter. So that is 10 Newton meter. And from the diagram it is clear that due to this force F1, the torque will be in anti-clockwise direction. So we can say 10 Newton meter anti-clockwise, or we can simply say plus 10 Newton meter is the torque. Second sub question is the moment of force F2 about point O. So torque is equal to F into D, but this time the force is F2, that is 3 Newton. Distance of the force 3 Newton from point O is 4 meter. So this is 12 Newton meter, and the direction of the torque is clockwise, or we can say minus 12 Newton meter. In third part, we need to find out the moment of force, moment of the two forces about point A, meaning we need to find out the net torque. So net torque is sum of anti-clockwise moment plus clockwise moment. Anti-clockwise moment is plus 10 and the clockwise moment is minus 12. So the resultant is minus 2 Newton meter, meaning the net moment of these two forces about point O is, we can say, 2 Newton meter clockwise. Fifth question. Two forces each of magnitude 10 Newton act vertically upwards and downwards respectively at the points A and B of a uniform rod of length 4 meter, and that rod is pivoted about its midpoint O as shown in the figure. Determine the magnitude of the resultant moment of forces about the pivot point O. Now here there are two forces, each one is having the same magnitude 10 Newton, but as you can see here the directions are reversed. Okay, they are acting opposite to each other. Also they are acting at different points, meaning these two forces generate what? Couple. Okay, these two forces generate couple. So here we need to use the formula of moment of couple, and the moment of couple is magnitude of any one force into distance between two forces. Distance between two forces. Magnitude of any one force, that is 10 Newton, into distance between the two forces here is 4 meter. So the moment of couple becomes 40 Newton meter. Of course, the direction of the resultant moment here is clockwise. Okay, the moment due to both the forces is in clockwise direction. So we can say 40 Newton meter clockwise is the resultant moment or moment of couple. Sixth question. Figure shows two forces each of magnitude 10 Newton acting at points A and B at a separation of 50 centimeter in opposite directions. Calculate the resultant moment of the two forces about point A, B and O situated exactly at the middle of the two forces. Alright, so in the first case, we want to find out the moment of force about point A. About point A meaning, what is the meaning when we say moment of force about point A? The axis of rotation is passing through the point A. Now since axis of rotation is passing through the point A, the torque because of this force acting in upward direction will be 0. Why? Because the distance between this particular force 10 Newton acting in upward direction and the axis of rotation is 0. So this particular force will not be able to generate any torque, or we can say torque due to that force becomes 0. So now we will be able to find out the torque only because of the force 10 Newton acting in downward direction. So torque is equal to Fd 10 Newton into distance of this force 10 Newton from the axis of rotation, which is at point A, is 50 centimeter. So 50, 500 Newton centimeter, and direction is, yes, you are right, clockwise. In second case, we want to find out the moment of force about point B, meaning now the axis of rotation is passing through the point B. So the force 10 Newton acting in downward direction will not be able to generate any torque since the distance is 0. So torque is 0. So torque due to 10 Newton acting in upward direction we can calculate. So tau is equal to Fd 10 Newton. Distance of this force from the axis of rotation is again 50 centimeter. So torque becomes 500 Newton centimeter. And what is the direction of the torque? That is clockwise. 50 Newton, 500 Newton centimeter clockwise. In third case now, the axis of rotation is at point O. Okay, axis of rotation is at point O. So now both the forces 10 Newton acting in upward direction and 10 Newton acting in downward direction, both of these two forces will be able to generate the torque. So we can say net torque here is nothing but moment of couple. Why moment of couple? Because these are the two forces equal in magnitude, opposite to each other and acting at different points. So moment of couple is magnitude of any one force into distance between the two forces, that is 10 into 50. So again the answer is 500 Newton centimeter, and the net moment is clockwise. Why? Because the force acting in upward direction generates the torque clockwise, and the force acting in downward direction also generates the torque in clockwise direction. So the net moment or the moment of couple is 500 Newton centimeter clockwise. Do watch the next video to find out the solution of further numericals. Thank you.